Okay, you're solving a system of linear equations, but it has fractions in it. So, first thing I'm going to do is get rid of the fractions. Get them out of there. They're causing problems. So, each equation, though, has to be dealt with separately. So, I look at the first equation, this one right here, and I have two denominators, a 3 and a 5. Now, you're only allowed to multiply by one number, so you got to choose that number carefully. That number has to be able to deal with both a 3 and a 5. And when I say deal with, I mean cancel out. You're literally going to multiply this equation by one number that the 3 and the 5 will divide into. It'll end up cross-canceling into. It's really kind of like finding a common denominator. The common denominator between 3 and 5 would be 15. Because 3 goes into 15 5 times, 5 goes into 15 3 times. So 15 is the number I would use. So I'm going to multiply this equation by 15, okay? So you're going to distribute that 15 to every single part. And there's 1, 2, 3 terms, 2 on the left of the equal sign, 1 on the right. But you have to multiply 15 times the 1/3 x, and then minus 15 times the 4/5 y equals, and then 15 times the -2. And when you multiply by 15, technically it's 15 over 1. But really putting the over 1's kind of a waste of time, because anything over 1 is just itself. And you're about to cross-cancel these fractions. So on this first one right here, it's like saying 3 goes into itself once, and it goes into 15 5 times. And then this mess right here, my numerator is 5 times 1 times x, which is 5x, over 1 times 1, which is a 1. But 5x over 1 is just 5x. That's what's going to happen. You're going to cross-cancel so that all you have left in the denominator is a 1. And you really don't need an over 1. It just goes away. On the next one, this 5 goes in itself once and goes into this 15 3 times. So I'm going to have the minus sign here, and then when I multiply all this, my numerators are 3 times 4 times the y, so that's 12y, all over 1 times 1, which is 1. But again, you don't need the over 1, so that's just 12y. Now over here on the other side, all I'm going to do is simply take 15 times -2. Since that -2 wasn't a fraction, I really didn't need to put that 15 over 1 at all. And 15 times -2 is -30. Okay? So there's that equation. I'm going to do the exact same thing to this other equation down here, except on this one, since my denominators are 6 and 2, all I need is a 6, because 6 goes into 6 one time, and 2 goes into 6 3 times. So just like the green up there with that 15, I'm going to distribute the 6 to all of these. Aww, follow me. I'm going to take 6 times the 1/6 x minus, take 6 times the 1/2 y equals, take 6 times the 2. All right. And then I'm gonna cross cancel. Let's see. On this first one, the 6's just cross cancel. They cancel out. So really what I'm left with is 1 times x, which is just an x. Then on this next one, the 2 cancels into the 6 3 times. So I'm left with this mess here of a minus 3 times 1y is 3y. And then that's just going to equal, this is just 6 times 2, so that's 12. So now what I have is this equation here and this equation there, which I'm going to take those two equations and either solve it by elimination by addition or by substitution. I have to decide. So I'm going to pause it and do another page. Okay, so here's those two equations that I came up with. And since my second equation over here, this x minus 3y equals 12, it is really easy to solve this for x. All I have to do is add 3y to both sides. That cancels. And I get x is equal to 12 plus 3y. So I'm going to use substitution. Since x is equal to a 12 plus 3y, I'm going to take that and I'm going to plug it in. Whoops, sorry about that. Kind of went a little crazy there. Plug it in where the x is, so that instead of 5 times x, I'm going to have 5 times a 12 plus 3y. And then what I have here is an equation with nothing but y's in it. I'm going to solve it for y. I will start by distributing the 5 here. 5 times 12 is 60, and 5 times 3y is a 15y. I stopped distributing the 5 because the parentheses ends right there, so you just copy down the rest of this. Okay, and then the positive 15y and the negative 12y, those are like terms. So you still have this 60, but then you can combine 15y minus 12y. That would be a positive 3y and still equal to negative 30. And now to solve for y, I have to get rid of that 60 next. So I am going to subtract 60 from both sides so that it cancels out here. I'm left with this 3y,